Hi everyone. So today we're doing the last lesson in Chapter 8. This is on solving equations with radicals. This note sheet was with the last set of notes that I handed out to you, so that would have been on Monday. So hopefully you've got this out in front of you. And this lesson is pretty straightforward. It shouldn't take us very long. It's pretty common sense based. With one kind of minor exception. There's one little hitch that kind of comes up that can screw people up a little bit. So we're going to get to that piece of it right away. So what I'm talking about is this thing called an extraneous solution. And an extraneous solution, I'll kind of talk through it first and then I'll write it down for you. But an extraneous solution is a solution that you get by doing everything correct mathematically. Okay, you have taken every step that you're supposed to, you've made no mistakes, you get an answer, and then when you take that answer and plug it back into the equation, it doesn't actually work. And the reason those arise, I think you'll see that as we work through some of these problems, but in this particular instance, the reason that happens is because of all those issues we've talked about with roots and when you're allowed to have negatives and when things have to be odd or even, there's a lot of restrictions here. And so if you come out with an answer that doesn't fit the restrictions of the original problem, it won't work for you. And so really what all of that means for you is that as we're doing these problems, even if you're 100% confident that you're doing them correctly, you have to go back and check your work, okay? So I'm going to go ahead and get rid of the picture here, and I will write down that definition for you. So an extraneous solution is a mathematically correct solution that doesn't actually satisfy the original equation. And so, like I said, even if you're feeling 100% confident, you do have to go back and check your work with these problems. Okay? And if you check your work and your answer doesn't hold up to be true, if it doesn't work out the way it's supposed to be, then it's not really the answer and you would just say no solution. Okay? So it is going to be important that we kind of check things out here. So, okay, so looking at that first problem, the cube root of x. Remember, when we're solving equations, we are all about how do we undo things. And so I want x by itself, which means I need to get rid of a cube root. And if you think about the opposite of doing a cube root, the opposite of doing a cube root would be a power of 3, or a cube. Okay? So if I cube a cube root, that's going to cancel out, but that means that I have to cube this side over here. And so I end up over here on the left with just x, and then 5 cubed is 125. Okay? So that's the answer that I come up with. But then, like I said, very important that you go back and check your answers here. So I'm going to go back to my original equation, which said the cube root of x. My x is now 125. Let me clear that junk. So I'm going to hit the cube root. And remember, to do that, you would type the 3 and then hit the math button and look for that one that's an x root, cube root of 125, and make sure it does actually come out to be 5. It does, so that checks, and so that is my final answer. Okay? All right. On that next one, number 2, kind of the same thing, except before we raise to a power of 4, we don't want to raise that 2 to a power of 4. So I would get rid of the 2 first, and we're going to do that by dividing. Divide. Just kind of move this over here. This is going to give me the 4th root of g minus 5 equals 5. Okay, 10 over 2 gives me 5. And then to get rid of my 4th root here, because I can't do anything with this stuff while it's still inside the radical. I have to get rid of the radical now. I'm going to raise this whole thing to the power of 4 and this whole thing to the power of 4. On the left there, my radical cancels, but this whole piece is going to stay intact. So I'm going to have g minus 5 equals 5 to the 4th is 625. And then I would add 5 to the other side, and I get g equals 630. And again, before I move on, I need to check and make sure that this isn't an extraneous solution. So I'm going to go back to my original problem. And I'm going to say 2 times, that's how you'll have to enter this, 2 times the 4th root of, so again, that 4 is indicating that should be a 4th root. And then because I'm putting more than one number under my radical on this calculator, I am going to have to put this in parentheses. And g is 630, so I'm going to do 630 minus 5. And what I'm hoping for is for it to come out to equal 10, and it does. Okay, so that means 630 is a legitimate solution here. Okay, so on the next one, number 3, start by dividing by 6. Get rid of that 6 out there. That's going to give me, I guess I'll squeeze this in here, 4th root of m squared equals 2. Okay, 12 over 6 is 2. Raise each side to the power of 4 to get rid of my 4th root. That's going to leave me with an m squared equals 16. Okay? And then this one's kind of weird because you end with a power. And so again, if you're thinking about solving is all about doing the opposites of things. So the opposite of squaring would be square rooting. Okay, so even though we just got rid of a root, now we're doing a root to get rid of the power. And remember that when you take a square root, we get a plus or minus, so this would be plus or minus 4 for the square root of 16. And once again, I'm going to check my answer. So I would do 6 times the 4th root of, and again in parentheses, that would be a 4, oh gosh, let's see. Yeah, that should work out okay. Trying to think about what that parenthesis should look like. Should come out to be 12. Yep, it sure does. And then I also need to check -4 because I'm saying there are 2 possibilities here. So I'm going to bring that same thing back up, except instead of a 4, I'm going to put a -4 in there. And it still comes out to be 12. So that solution's good too. So the extraneous solution isn't one that happens a lot, and we're going to kind of talk at the end about what kind of situations lead to an extraneous solution. Okay, let's take a look at number 4 here. Number 4, I have to get rid of that 3, but that 3 is not being multiplied like some of the ones up here were. To get rid of that 3, I would subtract a 3 because it is a positive 3. So now I have a negative. And that negative is not actually on the 4. It's like out in front of the root. So -4th root of y is equal to 7. And I know you're probably dying to take a 4th root right now, but before I can do that, I need to get rid of this negative sign. You can think of this negative sign as like a -1 sitting right there. So I would actually divide by -1, divide by -1, and that's going to give me the 4th root of y is equal to -7. And now I'm at a point where I can raise to the power of 4. So raise to the 4th, raise to the 4th. This all cancels. And y equals, let's see, I don't remember what this one is. -7 to the power of 4 is 2,401. Positive because you took a negative number and raised it to an even power. Okay, so let's go ahead and type that back in and check it out. And so that would look like this. 3 minus the 4th root. Gosh, I really like my 4th roots today, don't I? And that's just a y, so I'm just going to replace it with 2401. And it should come out to equal 10. And it does not. It comes out to equal -4. That means that this does not check out correctly. Now, before you make that conclusion, you will want to make sure that, first of all, you didn't make any mistakes back here and that you didn't make any mistakes typing it in, okay? Because both of those could lead you to think you have an extraneous solution when you really don't. But this one is extraneous. So that means this is not an actual solution, and we would just say there is no solution, okay? And that's the correct answer for this one. There's no solution to this equation. Okay, and then number 5. Number 5 is kind of a doozy. So for number 5, before I go any further with that, I'm going to kind of go off to the side here and do an easier version of this problem. And then we'll kind of compare it. So if this just said g plus 9 equals 4g. So basically I just got the roots out of there. I'm not actually getting the roots out of there. I am going to have to solve with the roots in a second, but wanted you to just see a general process here. Think about how you would solve something like that. I would probably subtract g and subtract g. And so that's going to give me 9 equals, and then 4g minus g is 3g. And then we could divide by 3, and we get 3 as an answer. Okay? We're going to follow that same general principle here because I have g's on both sides and they're both in roots, so I need to get them combined. So I would start by subtracting a 6th root of g and subtracting a 6th root of g. So this whole thing cancels. Here I'm left with just 9. This really messes people up. Remember, this is really like a 1 in front here. And so then what you're saying is if I have 4 apples and I take away 1 apple, what am I left with? Well, I'm left with 3 apples. Oops, that's supposed to be a G. Okay, so notice that my root, my radical, my variable does not change. Okay, it's just 4 of these minus 1 of these leaves me with 3 of these. Okay, so that one was kind of a tough one to get to that point. I would then take and divide by 3 and divide by 3. So now I end up with 3 equals the 6th root of g. And then let's raise to the power of 6. And I'm going to get, I believe, oh, I forget, 3 to the 6, 729, I think. Yep. So 729 equals g. And then before I commit to that, I better just check it. So I would start by doing the 6th root. Oh, you can't see what I'm doing, can you? 6th root of 729 plus 9. Now, be careful here. The way my calculator works, because it just gives me that short little radical there, if I just type one number there, my calculator is only taking the root of the 729. Let's go ahead and check that. Okay, and then we're going to have to figure out what this other side equals to, but just real quick, I want to show you what this might look like on some of the newer calculators. And of course, I don't have one easily within reach. Sorry about that. Try to move fast. Okay, so this would look like 6 root. Now see how this calculator actually puts the 6 up there? So when you type the 729, if you keep typing like that, that's putting the 9 underneath the radical, and you don't want the 9 underneath the radical. Okay, so on this calculator, after you type the 729, you've got to hit the arrow button to come out of the radical, and then you can put the plus 9 out there, and then you're going to get the same answer. You're going to get the 12. Okay? So I just wanted you to see the difference between the two. This is what I'm talking about when I refer to, are you on an older calculator or a newer calculator? The newer calculators all put it this way. The older ones kind of type it out like this, and that does make a difference in how you handle them. Okay, so on this one, we know that this side is equal to 12. What we need to know is, does that match what this side's equal to? So I would type in 4 times the 6th root of that 729. Okay, so that's what the right side of the equation says. It also equals 12, so because I ended up with 12 equals 12, I'm good to go. And that would be my, that would be my final answer. Okay, that's really it for today. It's just solving with radicals, and remember you can undo a radical with a power. Just make sure to check for extraneous solutions. Now, the good math teacher in me says you should check every single one all the time, okay? But the realist in me, the one who wants to kind of point you in the right direction, and if you're going to check any of them, let's check the right ones, wants to tell you that where you're going to run into issues. See how this one came out to be extraneous? See how I have an even root equal to a negative number? That's where you're going to run into trouble, okay? So I'm not saying that every single time you have an even root you're going to have trouble, but odd roots work no matter what, okay? Odd roots work with positives, negatives, whatever. So really it's those even roots that you have to watch out for, okay? So again, ideally you'll check every single one of these, but especially if you're in a problem where you're working with even roots and you've got negative numbers involved, that's where you're really going to want to make sure that you're checking closely, okay? Okay, so homework for tonight is Lesson Master 8.8b. It should be in your homework packet. I believe it's the last page in your homework packet, and I believe it's just the front of that. Do make sure that you're writing out all your steps and showing your work, please. Okay? Have a great day. I'll see you Monday.